Hi, and welcome to my inquiry presentation titled Creating Scientists, Providing Space for Scientific Creativity in My Environmental Science Classroom. My name is Charlie Plaisir. I am a St. Paul School BSTR Biology Teaching Fellow with a background in ecology and field research. Today, I will give you a rundown on a particular aspect of my teaching on which I was allowed to reflect over the past year. But first, let's see what we have in store for the next 10 minutes. This presentation will go into the different components that led me here, from the path I took as I was looking for a question of interest, all the way to my findings and their implications in my teaching today. Supported by literature-informed data collection tools, this presentation will act as a summary to the journey I went on with my environmental science students over the course of the year. So let's start with my path towards a question. Knowing that I am an ecologist by training, with an interest for the field of science communication, I came with a baggage from previous experiences as a science educator, leading to a set of values I wanted to emulate as I taught my class. I called them values to effective science communication. Now, coming from my background working on long-term field studies with kangaroos for a few years, led me to see science education as a collaborative process, with the objective to understand the world around us. From that came to mind the question, how can students develop their capacity to do science? Now, science is not always easy, otherwise everyone would do it. I therefore wanted my question to dig deeper than that. One thing I have realized about science is its need for one feature, one that schools have been blamed to hinder through their standardized structure and requirement for conformity: creativity. This word packs a lot of information. It's a word that can be defined in so many ways, yet everyone can identify it when it happens. What happens if I were to add science to that term, and then organize it into a better, catchier term, scientific creativity? It's already less clear, right? Well, quite frankly, that's what I wanted to see in my environmental science students this year. That is why I decided to ask the following question. How can I cultivate scientific creativity in my environmental science classroom? Let's shift gears now and look at the literature into which I decided to anchor my question of interest. And start with what we've all been waiting for, a definition of scientific creativity. In 2002, a publication about scientific creativity tests for our high school students was written by Wei-Bing Hu and Philip Adey, and it shared that scientific creativity requires a student to explore their own repertoire, to imagine a variety of routes to a solution, and frequently to create novel combinations of knowledge or novel techniques towards a solution. This article also found that scientific creativity increased with age, which encouraged me to focus on my seniors for this project. Similarly, the essential but not sufficient importance of science ability pushed me to wonder what other aspects of a student's experience might play out in scientific creativity. One of them was the perception of creativity by students. Lee and Park notably helped identify how parents gave more importance to learning-related aspects. Students focused on activities and teachers on thinking aspects of creativity. This helped me come to a consensus over the best method to introduce scientific creativity to my students and to their parents when I would see them. Something else that was pointed out by this article and others was the frequency at which personality tended to be associated with scientific creativity. Academic achievement, cooperation, psychological well-being, and confidence are all predictors of creativity. In recent science education literature, we've also seen a shift in focus from learning about science to doing science. Schwartz and Al pinpointed the next generation science framework that focuses on student ability to generate new knowledge using tools they have learned, while grappling with uncertainty, giving them a sense of epistemic agency or agency over the knowledge they interact with is essential to their development. I personally see scientific creativity as one of the means to promote that agency. With that uncertainty, although, comes an important sense of risk-taking. And who says risk-taking for teenagers also says hesitancy and refractiveness, which is why helping students become more comfortable with the scientific process is so important. Now, we have seen definitions of scientific creativity, perceptions, context, and individual traits, and how they all play out in scientific creativity. I use these 5 themes as pillars for the development of data collection tools needed to answer my question. As I was looking to encapsulate all of the following, I decided to use unit plans, assignments, assessments, teacher journal, and classroom recordings. All these tools play variable but complementary roles in the development of my findings that were diverse in many respects. Let's start with the fact that personality plays a role in scientific creativity. Some aspects are innate, others were acquired. but still unique to the student as they came in my class. I noticed in my teacher journals that the same students would appear more often than others with noteworthy oral interactions. While some would participate in class interrogation or clarifying interactions, others would most often ask questions challenging a process or information given in class, which was keeping me on my toes, let's be honest. The following graph summarizes what came out from my teacher notes. Here you can see how personality traits correlate with displays of scientific creativity. These traits are probably very correlated to each other. They all seem to be responsible for the multiple instances where I observed scientific creativity. Though this showed how my students did not start on an even playing field, it was interesting to see how I could focus on the different traits to increase every student's capacity for scientific creativity. Let's first start with asking questions and how to stimulate that. For that, students need to be exposed to learning contexts where questions may easily come to them, thus limiting the discomfort that comes with uncertainty. Using the Science on the Sphere room was a great tool to perform the latter, where I could make students observe lengthy geological phenomena in only a few seconds. Typically, a few prompts and guiding questions would get them thinking and trying to find patterns by writing investigative questions, which would help them make explicit connections that are more likely to be retained. I have also had a lot of feedback from students enjoying our trips to the SOS room, which was easily noticeable in their work, which brings me to my third finding, being the importance of care in scientific creativity. This trait, which most definitely appeared in some students over others, got me working. How do I make 13 students care about environmental science over the course of a single unit? Creative writing, in-class games, debates, term readings, documentary viewing, diving to the life of someone experiencing urbanization, all of the above. My students who showed greater creativity in their work often shared amazing feedback about the content or way they explored a certain topic. For instance, the joint elaboration of a complex board game to discuss population dynamics really took my students by surprise. And hearing them make complex connections as they were preparing the cards was really worth the development of this activity. Other assignments and assessments had a greater focus on general interests for my students. Some involved the creation of a recipe after being given a budget, family size, and city to prepare a meal in. Others were more local, looking at our food waste on campus and how to mobilize students to do more to reduce food waste. These tasks are typically lower stakes because of the amount of time and access to resources, but just as important as the student mentions here. Now, what happens when there's limited time and no resources to show evidence of scientific creativity? My next finding was looking at the importance of an appropriate challenge for students to be scientifically creative. Maintaining students in a zone where they can be challenged to make new connections while not being discouraged or feeling as though there's no possible solution is tough. Nakula and Toshalis discussed the zone of proximal development in chapter 1 of their book, Understanding Youth, Adolescent Development for Educators. This zone is typically fairly small and variable from one individual to the next, and the breadth of that zone diminishes with the stakes of the task, such as an end-of-term assessment. Asking students to take risks in trying to think originally towards a solution is a tough ask. Doing so while having them learn something within a broader curriculum is even more complex. Although I struggled with that, especially in assessments, where students were less likely to take risks and I could not provide full assistance, I noticed that it became less of an issue over the course of the year, partially due to the increase in knowledge content. There was a clear increase in trend in students' ability to make connections over the course of the year. It was certainly partially due to their level of comfort in class and capacity to develop complex thought as seniors. But knowing more about the inner workings of the world is clearly a key factor that allowed my students to make the connection I was hoping for. Now, let's summarize the 5 findings I decided to share with you here. So we talked about personality, context, care for the material, appropriateness of the challenge, and knowledge. They all perform key roles in the development of scientific creativity in my students. Although I am conscious there might be more out there, I'm confident taking all of the following into account as we design curricula will bring us closer to reaching that objective of developing more scientifically creative students. We can say that each of these findings harbors a different sense of control for the teacher or the student, and that emphasizes the fact that cultivating scientific creativity is a joint endeavor that can't quite be a one-way effort. Now, let's look at the broader implications of these findings for my teaching. First, I concluded that time is my best friend. Being flexible with time helps create a creative environment for all. I'm truly not a big fan of time assessments, especially when asking students to think creatively. Everyone has a different process to become better science learners. I therefore think time should become less of a constraint for students. One way to do so would be to increase the frequency of take-home assessments when aiming to develop a student's scientific creativity. Second, if we want students to care, we need to learn more about their individual interests. Not knowing what a student is interested in makes it extremely hard to provide an authentic teaching experience that will likely promote scientific creativity. Also, personality, as we talked about, encapsulates a lot of individual traits that the student brings with them at the start of the year. Getting to know the student before teaching them has been a major tool to help differentiate my teaching over the course of the year. Allowing them to know me as a person also helped me see them better through genuine interactions. Lastly, I believe students all have different ways of learning. Some will be more independent than others, and some will need their interests to be taken into account more than others. Some will need to grapple with uncertainty, while others will need everything to be clear from the start. This all needs to be understood and, most importantly, respected to bring them all to a new level of scientific creativity. With that, I would like to thank you for your attention, and feel free to visit my website for more information about the foundations of my teaching practice, questions about the data collection tools, or more details about the results of my inquiry project. Thank you.